So today we're going to focus on quadrilaterals. We're going to kind of zoom in on quadrilaterals. Yesterday, right, we talked about all kinds. What's that?
What page is that?
Oh, sorry, 419. My apologies. 419. 419 is where we're starting. Okay. So again, yesterday we talked about polygons in general. We talked about all kinds, depending on their, the number of sides, how we name them and stuff like that. Talked about like whether they were equilateral, equiangular, or regular. We talked about whether they're convex or concave. We talked about angle sums. We talked about finding an individual angle measure if we take the sum and divide by the number of angles. Now we're going to zoom in and focus, because this unit is mostly quadrilaterals. Yeah, we talked a little bit about polygons, but now we're going to focus mostly on quadrilaterals. Okay? And the very first quadrilateral we're going to take a look at is the parallelogram. Okay? So, we already know that a quadrilateral, right, is a polygon with four sides, so that's like kind of like an easy definition we know. A parallelogram, right, is a quadrilateral. It's a special kind of quadrilateral that has two pairs of parallel sides. It's kind of like, oh, well, it makes sense. We call it a parallelogram. It's got two pairs of parallel sides, okay? So that's kind of like important for us there. Two pairs of parallel sides, okay? I feel like you guys have probably talked about quadrilaterals before. Parallelograms before. You've probably heard it before, the name at least. So, there it is, okay? It has us doing an investigation here. We're not going to worry about doing that right now. We're going to kind of jump right in to the properties, okay, of a parallelogram. So, besides by definition, a parallelogram, again, by definition, a parallelogram is a quadrilateral that has two pairs of parallel sides. That's the definition. But there's some properties that come along with that too. For example, there's one property of a quadrilateral that says if a quadrilateral is a parallelogram, this is on the page 421, sorry by the way, page 421 now. We jumped a little bit there, page 421. If a quadrilateral is a parallelogram, then its opposite sides are congruent. Okay, opposite sides are congruent. And they have us prove that here, and I think we are going to do this proof because it's not too terrible if you actually take a look at it here. So, so the idea is, given that we have this parallelogram right here, we want to prove that the opposite sides of a parallelogram are congruent. And so we start with this given here that ABCD is a parallelogram, and we're given that we want to prove, that AB is congruent to CD. So AB is congruent to CD, and we also want to prove that AD is congruent to BC. Okay? So I know we haven't done proofs in a while, so we'll kind of like walk through this one together. Okay? So first step one here, it says that ABCD is a parallelogram. So why am I able to make that statement? It's given. That's right. So we know that's true because it was given to us. All right? Now, the next step is already given to us, and it's kind of like a funky step. It's just, the statement is draw segment DB. So if you notice here, they drew in segment DB. By the way, what do we call this kind of segment that connects two non-consecutive vertices? A diagonal. Exactly right. It's a diagonal. I didn't hear you, Jaden. I'm sorry. Diagonal. DB is a diagonal. So we drew in a diagonal there, and why can we do that? Well, because through any 2 points, we can draw one segment there. Now, the next statement says that AB is parallel to DC, and AD is parallel to BC. Well, how do we know that these opposite sides are parallel? What kind of shape is this? Well, it's a quadrilateral, but more specifically, it is a parallelogram. That's the definition of a parallelogram, right? The opposite sides are parallel. Okay, that's just the definition of a parallelogram. The opposite sides are parallel, and we just said that, okay?
I think our lesson should be on how to spell parallel.
Right, it is pretty tricky. It's just the word parallel with ogram at the end. Okay? It's just the word parallel with ogram at the end. All right, now the next one. The next one says that angle ADB, I'm going to mark these in here on my paper if I can find some color. Okay, here we go. Angle ADB, so here's ADB, that's this little angle right here, is congruent to CBD, that's this little angle right there, and also ABD, so that's this angle, is congruent to CDB, that's this angle. And there's no reason given, but what would the reason for that be? What would the reason for that be? I think not. It says 940, doesn't it, Zaria? 940? Say 840 or 940. 940. So you still got some time. That'll be next block. Okay. They just gave it to you early, I guess. That's all. So, how can we say it? Yeah, Taylor? Yes! We have alternate interior angles here. We have parallel lines. Remember those way back? When we have parallel lines crossed by a transversal, these are alternate interior angles. Those the double bars, the double angles there, right? The double lines, I should say. And then because these two sides are parallel, then ADB and CBD, these two single arc angles, are going to be congruent as well. And so, yeah, they're alternate interior angles. I'm just going to abbreviate that. Alternate interior angles are congruent. And I'll just use the congruent symbol. That way I don't have to write all that stuff. All right, ooh, this next step, right? This one is an easy one, too. DB is congruent to DB. What's the reason for that? Reflexive property, right? Reflexive. That's when something is congruent to itself. I'll just abbreviate the word property there. And so DB is congruent to itself. Oops, I'll put that in purple to kind of keep with the colors there. Ooh, and then the next one, we're not given the statement, but we're told angle, side, angle, triangle congruence theorem. So what are the triangles that are congruent here, Ikeva?
Shouldn't you just like label the triangles?
Yep, so what are their names?
Triangle ABD.
Okay, so triangle, let me write that down first, triangle ABD. So Ikeva was free, remember, to write the first triangle however she wanted to name it. But now the second one, she has to be careful how she names this one because she gave an order here. So where should you start here, Ikeva? Yeah, C, and then, let's see here, A, B. So look, you went from A to B to D. So from C, we don't want to go to B, because that's the short side, right? A to B is what you did. So we should go from C to D to B. Yeah, we have to be careful. C to D to B. It has to match up corresponding parts. And now that we've shown these two triangles to be congruent, we have that AB, which is part of that triangle, is congruent to CD, which is matching or corresponding to that other part, and AD is matching to CB. Remember what the reason is for this? When parts of triangles are proved congruent, what do we have? It's that 5-letter... I know, it's like there's C's and P's and T's in it, Mr. Wibb, but I don't know what the rest of it... Yeah, it's C, P, C, T, C. Corresponding parts of congruent triangles are congruent. Question?
For like stick.
Taylor, they want you ASAP, like right now.
Statements
In the office.
Like,
Office. Sorry.
instead of doing like ABD, could you do like the full like ACC or something?
You have to name, so because we are talking about these two triangles, we have to, like for example, this triangle has to use the letters A, B, and D in its name. And then this triangle that we've created from the parallelogram has to use D, B, and C in its name only. A is not part of this triangle down here. You see what I'm saying? Or did I answer your question?
Like, so you can't use like the full angle, you have to use like...
Yeah, you can't just use the full angle B, for example, because B is it's a different, it refers to a different angle in both triangles. In this triangle, angle B is the double angle, the double, like, arc there. But in this triangle, angle B is the single arc.
Yeah, so could you use like the full actual angle, like before it was like...
Oh, just say like full angle B and full angle D? Yes, we could, but then the problem is that we're not using, that's not part of any triangle that we have yet.
But if the lines are parallel, shouldn't they be equal? Like,
The opposite sides, you mean?
like, yeah, D and B.
We just proved it. Yeah, yes. Like you see it, but now we're proving it to be true. Yes. So yeah, you can see that. It's gotta be that way. But we also want to prove it. So this is one way to prove it. There's probably other ways to prove it true, but this is one way we did it by using congruent triangles. That's all. But absolutely, we can do it different ways. Is that okay? Good. All right. So very good. So again, the key thing to remember here is this. This is what you want to remember. if a quadrilateral is a parallelogram, its opposite sides are congruent. Okay, so parallelograms, their opposite sides are congruent. Let's turn the page, please. Okay. And I'm not going to, so the next property here, again, this is another property we need to know. If a quadrilateral is a parallelogram, its opposite angles are congruent. So not only are opposite sides congruent, opposite angles are congruent as well. We're not going to go through this proof. It's a very similar proof. In fact, we can pretty much use the same proof we just talked about here, okay, because we just proved these two triangles congruent, so that means what's going to be true about angle A and angle C? They'll be congruent as well. Look, they're in the same position. Sorry, they're in the same position. So angle A and angle C will be congruent, so we already know that those opposite angles are congruent, and then B and D will also be congruent. And again, it's kind of what Haley was able to see here. This angle matches up to this, the single one matches the single, and so B is made up of the same angles as angle D is, right? B has both a single arc and a double arc. D has the single arc and double arc, so they're going to be congruent angles. And so opposite angles are congruent in a parallelogram. Okay, another key property. All right? Skipping down there to the bottom, another key property. If a quadrilateral is a parallelogram, then its diagonals, we know what diagonals are, right? Diagonals join non-consecutive vertices. Okay, so like for example, DB here is a diagonal, AC would also be a diagonal. Okay. If a quadrilateral is a parallelogram, then its diagonals bisect each other. So that's another key property right there. Want to know that one as well. Okay. Again, for the quiz, you guys will have this available. You can use your notes and stuff. For the test, we need to have those properties down. It's kind of obvious, though, too. You kind of just like makes sense. Okay, the diagonals bisect each other. So that's what. That's.
So the other diagonal connects AC.
The other diagonal would connect AC, and those two together would bisect one another. They would cut each other into equal parts. All right, so turn the page once more. We're not going to do that other proof there either. I just wanted to do one so we could like kind of refresh our memory a little bit with the proofs. But I do want to try this problem right here. So we're on page. We're on page 424, okay, and we're going to now use properties of parallelograms. Okay? So, example 4 says ABCD is a parallelogram. That's important, right? We need to know it's a parallelogram. Right now, if we just look at the picture, it just looks like a quadrilateral. It might be a parallelogram, it might not, but we're told it's a parallelogram, so we can use the parallelogram properties, and we want to find each measure. Okay, the first measure we want to find is AD. Okay, now according to my picture I look over here, AD has a length of 7x. But of course, that means since the length is 7x, what variable do we need to find here? We've got to solve for x. We've got to figure out what is x. Okay, so what property of a parallelogram can I use? AD is a side, so what must it be equal to? It must be equal to the BC, which is also the 5x plus 19. Exactly right. So, using algebra, we can take that 7x and set it equal to 5x plus 19. Opposite sides in a parallelogram are equal. Okay. Opposite sides in a parallelogram are equal. And now we just solve this equation. That's all we got to do here. Thank you. All right. Make sure it doesn't happen again, please. Okay. So, Ikeva, how would we solve? Oh, sorry, we're on page 424 there, Taylor. Ikeva, how would we solve this equation? What's going to be our first step here? Yep, subtract 5x from each side. We want to get those x's together. They're on different sides of the equation, so we have to subtract 5x. We get 2x equals 19.
Oh, I wrote 14.
Oh, okay, yep, it's 19 in the problem. That's okay.
So you divide by 2.
And then, that's right, last step here is divide both sides by 2. And so we get x equals 9.5. And so we're done. AD's length is 9.5. No, it's not, Mr. Widmeyer. Come on, all right? What is AD's length?
AD's length is 9.5.
Yes, we got to put 9.5 in for x, okay? And the reason why I say that is because I always get students that, like, solve the equation, and back in algebra, right, when you solve the equation, you were done. But in geometry, right, because AD is 7x long, we need to plug that 9.5 back in for the x to get the measure. So AD is equal to 7 times 9.5.
Which is
66.5? Thank you. So 66.5. And that, not that, that is our final answer right there. AD is 66.5. Okay? So there it is. We use the property of parallelogram to help solve there and get the fact that AD is 66.5. So if AD is 66.5, what is BC's length? Yeah, got to be 66.5 as well. And in fact, if we plug in our x here, just check this out. If we plug in our x, 5 times 9.5 plus 19, there it is, 66.5.
So is that like the same thing like with angles? Like, you know how like you match up both sides?
Mm-hmm.
Like, would you do that with like corresponding angles?
So like these two right here?
Yeah.
So the next property, so the next one now says find the measure of angle B, right? So angle B, that is 6y plus 5 degrees. But what can we set that equal to? It has to equal the opposite angle, D. Remember, that's one of the properties of parallelogram. Opposite angles are congruent. So that means this one must equal this one. So we can say 6y plus 5 must equal 8y minus 17. Sorry, I'm off the screen there. There it is, okay? 6y plus 5 must equal 8y minus 17. Okay, and then we just solve this equation. So let's see here. So Ryan, to solve this equation, what's going to be our first step here? We have y's on both sides. Yeah, I always like to get rid of the smaller of the two numbers too. So subtract 6y from both sides. That leaves us with 5 equals 2y minus 17. And then what there, Ryan? You got it. Add 17 to both sides. So we get 22 is equal to 2y. And then what, Ryan? Divide by 2. You got it. So y is 11. Okay? So there we go. We got our y value. But Zaria, are we done? Sorry if you're still writing there. Are you done? Okay, so we got y equals 11, Zaria. Are we done then? Is that our final answer? Our original question here was we want to find the measure of angle B. Is angle B 11 degrees? Get your picture up there. What is angle B? It's, yeah, so what do we have to do with this 11 then? Put it in for the y. So we'll do 6 times 11 plus 5. So that's 66 plus 5, which is 71 degrees. So that's the measure of angle B. It's 71 degrees. Okay, if you want here, I don't know if I can zoom out some. Okay, yes, ma'am.
When you're solving that and you equal like those two together,
Yes.
I started with like subtraction 5 and like you get like a really weird number.
Okay, no, that it should still work. So I'll do that up here on the board real quick. So you had 6y plus 5 equals 8y minus 17.
Because I ended up with -2, not as my answer, but.
That's still, yeah, no, it's possible. Again, if you finish solving it, it should still solve to 11. So we had 6y minus 5 equals 8y minus 17. And you said you added 5 to both sides?
Yeah. Oh, no, never mind. It's 6y plus 5, so I would be subtracting 5.
Oh, sorry. Okay, yes, sorry. You're right.
Yeah.
Okay, so those cancel. I'm going to put 6y here, 8y here, and then minus 17 minus 5 is negative 22.
Yeah.
Then what'd you do?
And then I minus 8y.
Okay. We get negative 2y, right? 6 take away 8 is negative 2.
Yeah.
That's equal to negative 22, right? The minus sign stays with the 22
So
there.
how do you like you just divide by negative?
What's negative 22 divided by negative 2? Positive 11. So it does work out. There's lots, as long as you do your algebra correctly, yeah, you can do it that way. The negatives cancel. Okay? All right, so let's skip on to the next page here, page 425. All right, and let's look at this one here together. Now I'm going to call on some people here. So we have another parallelogram, PQRS. We want to find each measure. Now notice here we have PQRS, but what else is drawn in here? What are these things? They look like triangles, but what do we know they're called in polygons? Diagonals. PR, SQ, those are diagonals. And we know a property of parallelograms. We have a property that deals with the diagonals, don't we? So let's look at here. Number 8, We want to find QR, okay? So QR, Josh, what should QR, that's 3z minus 4, what property can we use, or what property can we use to write an equation here using QR? What else, what can we relate that QR to be equal to? Exactly right. Yep, the equation is 3z minus 4 equals 2z plus 4. Great job there, Josh. Exactly right. Opposite sides of a parallelogram are congruent. Okay, so, Maddie in the back. We want to solve this equation, Maddie, okay? So what should we do first here to get this, start solving this equation? Yep, subtract 2z from both sides. That works. Okay. Whoops, I shouldn't have canceled that one out. 3z minus 2z is just 1z, or just z. And then what, Maddie? Oh, okay.
Was that just 4?
It's z minus 4 equals 4. And then what, Maddie? We have z minus 4 equals 4, so to get the z by itself, what do we do? Add 4 to each side, you got it. And to get z equals 8. Okay, we get z equals 8. Kayla, are we done? Have we answered the question? Okay, what do we still have to do here, Kayla? Yes, okay, so QR is 3z minus 4. So 3 times 8 minus 4, that is QR, which is, whoops, I don't know why I put in the parenthesis there, that's kind of silly. So, yeah, 3 times 8 is 24, minus 4, it is 20. Thank you, guys, very good. So 20 is our answer there. Great, good job. Questions on any of that? All right. All right, so number 9, and let's do this last one here together. Number 9, for this section, I said, we're going to look at one more thing here, too. Number 9, PR. PR, okay, so we want to find the length of this diagonal here, PR. Okay. Ooh, that one's pretty tricky here. Let's see. I'm going to... Xander, any ideas here? How could we relate, how could we set up an equation here using this information? If I want to find the length of PR, any idea here, Xander, about how you can set up an equation here for this? Not sure? Zari, what do you think?
I did plus 9 4x plus 8.
Oh my gosh, yes, x plus 9, this piece must equal 4x minus 6. Remember, the other property we haven't yet used is that the diagonals, so PR is a diagonal, SQ is a diagonal, the diagonals bisect each other. What does it mean to bisect? Cut into 2 equal pieces. So SQ is bisecting PR, cutting it into PT and TR, and those are going to be equal. So Zari is exactly right. X plus 9 equals 4x minus 6. Okay? So, Xander, now what? How do we solve this? What do we do? To solve this equation, what do we do? You can just look at mine up here. Can you see mine okay? Yeah. Okay. So how we solve this equation? What's going to be our first step here? So we can add 6 to both sides. That's one thing we can do. Yep. Okay. X plus 15 equals 4x. And then what? Subtract 1x from each side. I'm just going to, write that there. And I'm going to run out of space, so I'll do it down here. And so those cancel. I get 15 equals 3x. And then? Divide by 3. You got it.
Could you do it the other way? Because
so did you subtract x from both sides first? All right, so let's do that real quick. Zari asked to see it the other way just to make sure here. So subtract x from both sides. Okay, so those cancel. We still have the 9 left over there, right? 4x take away an x is 3x minus 6, right? And then what? Yeah, plus 6 to both sides. I get 9 plus 6 is 15 equals 3x. And so you still should get x equals 5 then. Ah, okay, gotcha. All right, so, Garrett, x equals 5. Have we answered the question that was being asked? Is 5 the measure of PR? Well, if you look here, PT, which is part of PR, is x plus 9. So the x equals 5. Is the full length here, PR, is that a measurement of x? It's not, it's a measurement of x. PT is the length of x plus 9. So what does that mean PT's length is? If we know that x is 5, how can I find PT's length? What would I do? Yeah, put 5 in for the x. So PT is equal to 5 plus 9, so that's 14. And then what about TR? What would I do there, Garrett? So put what in for the x? 5 in for the x, that's right. So again, TR is equal to 4 times 5 minus 6. So let's see, 4 times 5 is 20, minus 6 is 14. But we shouldn't be surprised by that, right, guys? Because we know that the diagonals bisect each other. So if we know PT is 14, TR had better be 14, right? So, and then last step here, Garrett, to get the length of PR, what do we have to do? Add them together. Yep. Okay. Instead of finding the length of PT and TR and then adding them together, what else could we have done here? If we just, for example, found PT, what could we then do to get the full length PR? Just multiply by 2. Exactly right. You could also just multiply by 2. Yep. So there it is, 28. All right, questions on any of that? All right, you guys are doing real good on that. So we're going to skip ahead just to one more thing I want to look at. Okay, we're going to look at the conditions for parallelograms. This is on page 433. This is going to go real quick here. Okay, I'm going to kind of zip through this because, well, you'll see, it's really straightforward. So page 433, this is going to be super quick. Okay. So all those problems we just talked about, those were, if we're given that something's a parallelogram, then these properties are true. So if it's a parallelogram, opposite sides are congruent. Opposite angles are congruent. Diagonals bisect each other. Okay? If we have a parallelogram, then those properties are true. If the opposite is true, then we can, you can also go in the opposite direction, I'll say. So for example, if I'm given like a random quadrilateral right here, notice I am not told this quadrilateral is a parallelogram, but what are we shown? I have that AB and DC are congruent, and I have that AD and BC are congruent. What is this showing? It's showing opposite sides are congruent. Well, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So before we started with, if it's a parallelogram, then opposite sides are congruent. Now we're starting with, if opposite sides are congruent, then the quadrilateral is a parallelogram. Okay? So it's kind of working backwards now, trying to determine if a shape is a quadrilateral. Likewise, we only need if one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram. So we only need one pair of opposite sides of a quadrilateral to be parallel and congruent. The quadrilateral must be a parallelogram. Okay. Similarly here with the opposite angles. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So right here, if A is congruent to C and B is congruent to D, that must be a parallelogram. Has to be. Can't be any other shape. And of course, also the diagonals property. If the diagonals of a quadrilateral bisect each other, so again, just a random quadrilateral here, we don't know it's a parallelogram, but because the diagonals bisect each other, cut each diagonal into 2 equal parts, then we know that shape is a parallelogram for sure. Okay, so you can turn that page there. Okay, so I just want to show you on page 437 then, so here's a different set of directions here. So we want to show that each quadrilateral is a parallelogram for the given values of the variables. Okay, so before we were just using the properties to find the lengths of sides. Here we're trying to see, is this thing a parallelogram? Okay, there you go. You're welcome. So we're trying to determine, is this a parallelogram? So the way we do that is we're going to see, all right, well, let's see here. If we're told that x is 7 and y is 4, so if x is 7, what does that mean BC's length is going to be? Well, 7 plus 14, so it's going to be 7, that's 21. Okay, so that side has a length of 21. AD is 3 times x, so that's going to be 3 times 7. That's equal to 21. Okay. So is that good, the opposite sides are the same measure here? Is that what we want? Yeah, that's what we want, right? We want to see that those opposite sides are congruent. Is this enough to say that that this shape is a parallelogram?
Yeah.
We have one pair of opposite sides congruent. Is that enough?
Yes.
No. We need two pairs of opposite sides. We need two opposite sides congruent. So we got to look at this one right here, 5y minus 4. We'll plug the 4 in for the y. Okay, so 5 times 4 is 20, minus 4 is 16. So that's this side length. And then it's also 16, yeah, 2 times 4 plus 8. So that's 8 plus 8 is 16. And so that's this side length. Now can we say it's a parallelogram? We can. We have but that's just it. We don't even need that. As soon as we show that opposite sides are congruent, we know the whole thing's a parallelogram.
So what if you got a shape can you get a shape with the sides that are like that, but the angles are not?
No, it's impossible. If you have opposite sides congruent in a quadrilateral, opposite sides congruent, the shape is a parallelogram. Must be. There's no way to make it any other way, so it's not a parallelogram. Okay? So yeah, it is a parallelogram. So A, B, C, D is a parallelogram. Opposite sides are congruent. Okay? Likewise down here, I'm not going to do this one because I think you guys get it. I don't want to beat a dead horse here. But in this case, we have angles. So to show that this shape, is a parallelogram, what we want to show in this case?
9, and then put the 11 in for the z.
Put the 11 in for the z's, and we want to see that angle F is how related to angle H. How should F and H be related? They should be equal. And what about, is that enough though, just to show that F and H? We also got to show that E and G, and again we put the W, the 4.5 in for the W. So you just put those in and then see if they are in fact congruent. We're not going to do that because I think you guys get it, and I don't want to spend extra time on something that you guys have no problem with now. Okay? Show.
So basically the angle, say the angle, so E has to be the same as G.
E, when you plug the 4.5 in for the W, would have to be the same as G when you plug the 4.5 in for the W. It's simple. That's opposite angles. If opposite angles in a quadrilateral are congruent, then you know you have a parallelogram.
Wait, so we times it by 11? We put the...
It would be 11, yeah. 11 times 11 minus 3. And then 9 times 11. I mean, yeah. I can just show you here real quick. So 9 times 11 plus... Actually, I'll do it up here. 9 times 11 plus 19. Here we have 11 times 11 minus 3.
They're not equal.
So 9 times 11 minus 19. It's not. This is 80 I got for that one. And then 11 times 11 minus 3.
22.
Oh, I put it... Wait a minute. 9 times 11 plus 19. Whoops, I subtract 19. Whoops, so that's 118, yeah. And 11 times 11 minus 3, 118 as well. And then, yeah, careful. And then 12 times 4.5 plus 8. I get 62 degrees for that one. And then 14 times 4.5 minus 1. I get 62 degrees is there as well. So opposite angles are, in fact, congruent. Okay? And so this is a parallelogram. Okay? If opposite angles were not congruent, then you would conclude this is not a parallelogram. Okay? Still could be a quadrilateral, but it's not a parallelogram.
Would you ever have a problem where it's angles and sides?
Could be. So if we look at the next one here, and we'll just look at this one real quick, and this one's kind of different, but then we'll be done. Last one, I promise. This is the last one. Okay? So here we have angles and sides. Okay? You'll notice here, folks, that we don't have enough to use the opposite sides. We have one pair of opposite sides, but we would need both pairs of opposite sides. We also don't have enough information to say anything about opposite angles because we don't have any opposite angles. Okay? But if we can prove that these two angles are congruent, which I believe they are, 7 times 2.4, and then 2 times 2.4 plus 9. So, did I make a mistake here? Plus 12, not plus 9.
What angles are you talking about?
Hold on a second, I'll be right with you. Let me get that. Let me just do this. 7 times 2.4, and then 2 times 2.4 plus 12. Okay, so they're both 16.8, and then these two angles right here, Q and R. Okay, if we plug in B for those, so this is both that 16.8, That's 16.8. But then if I plug in the b, I get 10 times 9 minus 16, which is 74 degrees. And then 9 times 9 plus 25, that's 106 degrees. They're not opposite. But how are these two angles related? If you were to, how can anyone see how these two angles are related? They're not. Yeah, they make 180.
Triangle.
They're on the same side. Yeah, same side interior or co-interior or consecutive interior. Since these things are supplementary, what's going to be true about segment QP and segment RS? If they're supplementary, that means these two angles are going to, these two sides will be, well, they add to 180. That's what those two angles do. But then these two sides will be parallel. And since then we have congruent sides that are also parallel, that shows that this is a quadrilateral or a parallelogram as well. Okay, that's one of the other properties. We talk about that one. It's right here. If one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram. And so that's that situation right here. We have one pair of sides that are congruent and they're also parallel based on what the angle measures are there. Okay, so congruent and parallel, that's a parallelogram. Okay? Any other questions on any of that? So again, your big properties. I know it's like beating a dead horse here, right? But if you're looking to make a parallelogram, opposite sides are congruent, opposite angles are congruent, and the diagonals bisect each other. Okay? Those are the big properties to remember. So, for your assignment, all right, we're going to look at page 427. You guys have a good bit of time to get started, too.
So, like, what do you end up doing? Looking at solve if it's a parallelogram?
If it's not a parallelogram?